Okay, we are going to start with the first question for today, that is October-November 2016, question number 1 from paper 1-3. The question says that find the set of values of k for which the curve, this is the curve and this is the line, they do not meet. Do not meet means that b square minus 4ac, it will be less than 0. So first of all, we'll find out the equation for the point of intersection. So we'll equate the two lines together. For that, we'll put the y's and y's equal to each other, and so it will become kx square minus 3x equals to x minus k. Now we'll simplify the like terms. Minus 3x minus x plus k equals to 0. So the equation that you will have will be kx square minus 4x plus k equals to 0. Now we know that the line and the curve, they do not meet, so it means that b square minus 4ac, it will be less than 0. So the value of b is minus 4 square, 4 times a is k and c is also k, and it has to be less than 0. Now when we simplify, it will be 16 minus 4k square less than 0. Now what we can do is we can convert it into an identity, which identity can be we can in fact take 4 as a common as well first. So if we take 4 as common, we'll have 4 minus k square inside less than 0. So if we divide both sides by 4, we will be left with 4 minus k square less than 0. Now we can see that this is the identity we can have, a square minus b square. So it will become 2 plus k. Yeah, yes. But even if you include it, you will get the same results. I am just simplifying for the easiness, nothing else. I said I am just taking out as a common for the easiness. Otherwise, if you continue with the same method to apply the identity, you would definitely get the same results. Okay, so even if you take 16 minus 4k square and you apply the identity of a square minus b square on it, you'll get the same results. Okay, now if we find the critical values for this, one critical value will be plus 2 and the other critical value will be minus 2. Now if I sketch the graph for this, and I see that the critical values over here, one is minus 2 and the other is plus 2, and since it says that the region is okay, but there is another need of that, and that is we need to change that form. What we can do is, one more thing we need to do over here, and that is minus k square plus 4. Now we can take negative common from both sides. So if I take negative as a common, it will become k square minus 4 less than 0. But now if I divide both the sides with a negative sign, it will change the inequality sign. So I will be left with k square minus 4 greater than 0. Now if I apply the identity, one time it will be k plus 2 and the other time it will be k minus 2 greater than 0. Now if I sketch the graph, the critical values are positive 2 and negative 2, negative 2 and positive 2, and it says the region above that. It says that greater than means the region above the x-axis. So these are the two regions that he is talking about. So one value of k will be for the left hand side portion, one value will be of k less than minus 2, and on the right side the value of k will be greater than positive 2. Yeah, is that clear? Makes sense to you? Sorry? Sorry? Yeah, yeah, look, it does not meet, na? Yeah, it does not meet. I have applied the discriminant will be lesser than 0, and I have kept the discriminant to be lesser than 0 throughout the question. But over here in the second last step over here, I have to make it look like the identity, which is a square minus b square. And to make it that, I will take a negative as a common. Yeah, because it has to be in the form of k square minus 4. Earlier it was 4 minus k square. So to arrange it, to make the arrangement only, I have rearranged so that it becomes k square minus 4. And yes, remember, whenever you divide both sides by a negative number or multiply by a negative number, the inequality sign in the center, it changes itself. So that's the reason I changed the inequality sign from lesser to greater. I have just summarized it, that look over here, did I not divide the left hand side with negative 1? So I'll also divide the right hand side with negative 1 as well, right? So when I divide or multiply both sides with a negative number, remember the inequality sign flips. If the inequality sign is less than, it changes into a positive sign, greater symbol, and otherwise as well. If you multiply and divide both sides by a negative number, the inequality sign reverses itself. Okay, so and that's the reason I have changed the lesser symbol into a greater symbol, because I was dividing the left hand side with a negative 1 and right hand side also with a negative 1. Yeah, makes sense to you? Yes. Let's move to the next question, 27, which is May June 2017, question number 3, paper 1-3. He says that find the coordinates of the point of intersection of the curve. This is the curve that we have. The first one is a curve, and the second one is also another curve. So we need to find out the coordinates for the point of intersection. So do you remember what do we do when he ever talks about meet or intersection? Whenever he talks about meet or intersection, it is always that we put both the equations equal to each other. We substitute the equation into one another. So we'll write x power 2 by 3 minus 1, it will be equal to x power 1 by 3 plus 1. So if I simplify, it will become x power 2 by 3 minus x power 1 by 3 minus 1 equals to 0. Now the equation that I have is this. Now this is the complex equation. How can we solve it? We can see that instead of writing x power 2 by 3, we can write it as x power 1 by 3 whole square. So we can substitute u as another variable and we can label it as x power 1 by 3. So the whole question will become u square minus u minus 2 equal to 0. Now this is the quadratic equation we have and we can easily solve it. So the factors that we are going to have will be minus 2 and minus 1. So u square minus 2u plus 1u minus 2 equals 0. U is a common, plus 1 is another common. So the brackets that we have is u minus 2 and the other bracket is u plus 1. So the two values of u we will find is positive 2 and negative 1. So we have the values of u with us. Now we know that u is equals to x power 1 by 3. So we'll substitute 2 equals to x power 1 by 3 and minus 1 is also equals to x power 1 by 3. Now we know that it is a power on the right side. When we flip it to the other side, it becomes 2 power 3 equals x and minus 1 power 3 equals x. When we take the power to the other side, the power flips itself. So the two values of x we will have is 8 and the other value of x is going to be minus 1. Is that clear to you? Yeah, I'll repeat that. Can you see that the power on the right hand side is 1 by 3? When you take the power to the other side, the power flips itself. By flip I mean the power 1 over 3 will become 3 over 1. Okay, remember whenever you take the power to the other side, the power flips itself and it becomes if it's 1 by 3 it becomes 3 by 1. If it's 1 by 2 it becomes 2 by 1. Yeah, sorry. Now what we can do is we can substitute these values of x in any one of the above equations. So y is equals to 8 to the power of 2 by 3 minus 1. So it will be 8 power 2 by 3 minus 1. The value for y from here, it will be plus 3. And similarly you will put the value of x in the other one as well. So minus 1 and that's give us 0. So the 2 points of the coordinates for the point of intersection will be 8, 3 and the other one will be minus 1, 0. Is that clear? Okay, let's move forward to the next question, question 28, which is from October-November 2017. Question number 2, paper 1-3. He says that find the set of values of A for which the curve and the straight line meet. So there is another keyword over here which is meet. So which means that you need to put both the equations equal to each other, and they meet at two distinct points. So whenever he says two distinct points, so he means that the discriminant has to be greater than 0. So b square minus 4ac has to be greater than 0. Now before that we are going to put the curve and the line equal to each other. We'll put y's and y's equal to each other. So it will become minus 2 divided by x. It will be equal to ax plus 3a. Will cross multiply, so it will become ax square plus 3ax. If we further simplify, ax square 3ax plus 2, and it will be equal to 0. Now this is the equation for the intersection, and he says that the line and the curve, they intersect at two distinct points. So by two distinct points he means that b square minus 4ac will be greater than 0. So we'll just simply substitute these values in here. The value for b square, b is 3a, so 3a square minus 4 times a times c is 2, and it has to be greater than 0. So 9a square minus 8a greater than 0. Now we can take a as common. We will have 9a minus 8 greater than 0. So the two critical values that we can have, the critical values will be a can be 0, and the other critical value can be a will be 8 over 9. Yeah, sure. Now we can sketch the graph. If we sketch the graph, the two critical values are going to be one is going to be a 0 and the other is going to be 8 by 9, and he said that it's greater than 0, so it means that the region above the x-axis, so these are the two regions that we will have. So the right hand region is going to give us the value for a to be greater than 8 divided by 9, and the left hand side region, it is going to give us the value for a lesser than 0. So these are the two values, inequalities for a that we will have. Yeah, is there any question? Yeah, any question to anyone? Yes. Shall we move forward? Okay. Let's move to the next one, that is question 29, May-June 2018, question number 2 from paper 1-2. The question says that the equation of the curve, which is y is equals to x square minus kx 6x plus k, where k is a constant, find the set of values for which whole of the curve lies on the x-axis. So lies on the x. Sorry? No, he means that you need to find all set of values of k for which the curve lies above the x-axis. No, you're not reading the question properly. He says that the curve lies above the x-axis. Above the x-axis means that it is not intersecting the x-axis. Okay, yeah, so it means b square minus 4ac less than 0. Greater than means that they are intersecting at at 2 points. If they are not intersecting, it means it's lesser than 0. So let's apply b square minus 4ac less than 0 minus 6 square 4 times a times c less than 0. So it's 36 minus 4k less than 0. So if you simplify, it will be minus 4k less than minus 36. Do you see we have a negative sign over here? So I have to divide the left hand side with negative 4, and I have to divide the right hand side with negative 4 as well. So if you divide both sides with a negative sign, the inequality sign flips itself. So the values in the set of values for k will be greater than 9. Yeah, is that? When you move the negative 4 to the other side, it is basically you are dividing both sides with a negative number. That's the basic scenario you are doing. Okay? You just have to remember one thing, and that is that if you have a negative symbol with the variable, you always have to change the inequality sign. Yeah, will that make sense more? Okay, now the next part says, the second part, find the value of k for which the line is tangent to the curve. So tangent to the curve means that first we need to find out the equation for intersection for which we will put the y's and y's equal to each other. So it will become x square minus 6x plus k, and it will be equal to 7 minus 2x. We'll make the y subject over here, and it will be 7 minus 2x. Yeah, is that clear to you? Now if we simplify, it will be x square minus 4x plus k minus 7 equals to 0. Any problem so far? Now since the question says that the line and the curve, they are tangent to each other, so it means that b square minus 4ac, it will be equal to 0. So let's substitute them into the discriminant. B square minus 4ac will be 0. The value for b will be minus 4 square. 4 times a is 1 and c is k minus 7, and it will be equal to 0. It will become 16 minus 4k plus 28 equal to 0. So it will be minus 4k equals to minus 44, and the value for k will be positive 11. Yeah, makes sense to you? Let's move to the next question, question 30, in which a standard form of quadratic equation is given to you, and he is asking you to convert the standard form into completed square form. So what is going to be the first step? For the first step, we will take 3 as common. We'll have x square minus 4x inside. Remember, you should not take common from 7. After that we need to do the half of the coefficient of x. Half of 4 is 2, so you will add the square of 2 and you will subtract the square of 2. Now if you just have a look at the first three terms, they are always going to make an identity for you. If there is a negative sign, it is going to be a minus b whole square. Otherwise, if both of them are positive, it's going to be a plus b whole square. So 3 bracket x minus 2 whole square minus 4 plus 7. Now if you expand, it will be x minus 2 whole square minus 12 plus 7, and the final answer will be 3 bracket x minus 2 whole square minus 7 minus 5. Yeah, any problem so far? No, is there any problem? Any problem to anyone? Let's move to the next question. Question number 31, October November 2018. Question number 1 from paper 1-1. Okay, the question says, so what you need to do is, it's a complex equation. So what you need to do is you need to substitute another alphabet for that. But before doing that, let me tell you one thing, that x power 1 by 2 multiplied by x power 1 by 2 is equal to x. If you multiply x power 1 by 2 with x power 1 by 2, it will always be equal to x. Make sense to you? Now this x written over here, this is basically x power 1 by 2 times x power 1 by 2. So what you will do is you will label u as x power 1 by 2. Now this 4x, I told you just now that this x means x power 1 by 2 multiplied by x power 1 by 2. So this 4 will become 4u square minus 11u plus 6 and equal to 0. So it is 4 times 6, which is 24. So the two factors that you are going to choose, they will be minus 8 and 3. So 4u square minus 8u minus 3u plus 6 equals to 0. So 4u is common, so u minus 2 inside, and for the next minus 3 is common, u minus 2 inside. So the two brackets that you will have is u minus 2 and 4u minus 3. So the two values that you will find for u is u will be 2 and the other value for u will be 3 by 4. These are the two values for u. Now these are the two values of u, but remember he's not asking you to find u, he's asking you to find out x. Now x is basically equal to u is equals to x power 1 by 2. So you will write down 2 is equal to x power 1 by 2, and on the other side it will be 3 by 4 is equals to x power 1 by 2. Yeah, now when you will take this power to the other side, it will flip on the other side. So it will become 2 power 2 equals x, and on the other side it will be 3 by 4 power 2 equals x. Now the two values of x that you will have, let me write them here. One value of x will be 4 and the other value, one value of x that you will find is 4 and the other value of x will be 9 by 16. Yeah, any problem to anyone so far? Okay, let's move to the next question. Question number 32. October November 2016. Question number 2, paper 1-1. He says a line has equation y equals to x plus 1 and a curve has equation this. Find the set of values of the constant b for which the line meets the curve. Yeah, he says the line and the curve, they meet. There are two cases in which no, just read the line again. He says that the line and the curve, they meet each other. There are two cases in which the line and the curve, they meet. Do you remember both these cases? One case is when the line and the curve meet at two distinct points, and the other case is when the line and the curve, they are intersecting or they are just tangent at one single point. He is not being specific which thing he is talking about. So whenever he asks such a scenario, you always put greater and equal to. You always put b square minus 4ac greater equal to 0. Do you understand? Remember in the previous questions, either he says that the line and the curve, they meet at two distinct points, or he says that the line and curve, they are tangent to each other. He was very specific, but in this scenario he says that the line meets the curve. So he is not being specific that which scenario is he talking about. So whenever this is the situation, you always put b square minus 4ac greater than or equal to 0. Now let's first find out the equation for intersection, and that will be by putting the y's and y's equal to each other. So it will be x square plus bx plus 5 and it will be equal to x plus 1. So x square plus bx minus x plus 4 equals to 0. Now you can take x as common and b minus 1 inside. Now we know that b square minus 4ac has to be greater than or equal to 0. Let's substitute the values in here. B square minus b minus 1 whole square minus 4 times 1 times 4 greater than and equal to 0. So it will become b minus 1 whole square minus 16 greater than and equal to 0. Can you see you can apply some identity now? Which identity do you think you can apply? You can apply a square minus b square, which is a plus b, a minus b. Now how will you apply it? The entire question will look like this. So whenever I talk about a, it is b minus 1, and when I talk about b, it is 4. So if one time I will add it and the other time I will subtract it according to the identity, which is a plus b and a minus b. So it will become b plus 3 and b minus 5. greater than and equal to 0. Yeah, is there any problem? Now we'll sketch the graph. The two critical values are -3 and +5. -3 and +5. From here you will have the critical value as -3, and from here you will have the critical value as +5. Now if you look at the inequality in your question, it says greater than. So greater than means the region above the x-axis, and so I have shaded in both the cases. So the two inequality solutions for B, the left hand side is going to give you B less than and equal to -3, and the right hand side will give you B greater than and equal to +5. Is that clear? Do you understand there has to be an equal sign in this case as well? Okay, let's start with the next question, question number 33, which is from October November 2018, question number 10, paper 1-2. The question says that equation of the curve is y equals to 2x plus 12 over x, and the equation of the line is y equals to k minus x, where k is a constant. Find the set of values of k for which the line does not meet the curve. So the line does not meet the curve means that b square minus 4ac, it will be lesser than 0. So first of all we will find the equation of intersection. For that we will put the y's and y's equal, and it will make us 2x plus 12 over x, which will be equal to k minus x. 2x square plus 12 equals kx minus x square. So if you simplify, you will have 3x square minus kx plus 12 equals to 0. This is the equation for intersection. And now he says that the line does not meet the curve, so which means that b square minus 4ac, it will be less than 0. So minus k whole square, 4 times 3 times 12, and it will be less than 0. So k square minus 144 less than 0. So it will become the identity k plus 12 and k minus 12 less than 0. So if I sketch the graph, the critical values are going to be minus 12 and plus 12. And since the inequality says that the region is below less than 0, so it means the region below the x-axis. So the region below the x-axis means that minus 12 will be the minimum value, less than k and less than 12. These are going to be the set of values for k. Okay, let's move forward. The B part, in the case where k is equals to 15, the curve intersects the curve and intersects the curve. It means the curve intersects the line at point A and B. At point A and B. So you need to find the coordinates of A and B. We already have the equation for intersection that we just found out above. That was 3x square minus kx plus 12, and it will be 0. So 3x square minus 15x plus 12 equals to 0. We substituted the value of k that was given over here in this case. So it's 3 times 12, which is 36. So the two factors we need to find out, they will be 36 12 and 3, So it will be 3x square minus 12x minus 3x plus 12 equals 0. So 3x is common, x minus 4, then minus 3 is common, x minus 4. So the two brackets will be x minus 4 and 3x minus 3. It will be equals to 0. So one value of x is 4 and the other value of x is 1. So these one of the x coordinate is going to be for A, the other one will be for B. We can substitute it in any of the above equation, which is y equals to k minus x. The value of k is 15 minus 4, which is 11, and similarly y will be equals to 15 minus 1, which will be 14. So the two coordinates that you are going to have will be 4 comma 11 and 1 comma 14. Let's move forward. He says that find the equation of the perpendicular bisector of the line joining A and B. So first we will find out the gradient of AB. The gradient of AB will be 14 minus 11 divided by 1 minus 4, which will be minus 1. Minus 1 will be the gradient of AB. So the gradient of perpendicular bisector of AB will be positive 1. Now the word bisector means that the line is passing from the midpoint. So we need to find out the coordinates of the midpoint of AB. So which will be 4 plus 1 divided by 2, 11 plus 14 divided by 2. So the coordinates of the midpoint will be 5 comma 2 divided by this is going to be 25 divided by 2. Now we have the coordinates from which the line is passing and we have the gradient as well. So we'll apply y minus y1 equals m into x minus x1. So y minus 25 by 2 m x minus 5 by 2. So y is equals to x minus 5 by 2 plus 25 by 2. So the equation for the perpendicular bisector, which will be 20 by 2, which will be x minus 10. It will not be minus, it will be plus 10. Okay, let's move forward to question number 30. If there is any question regarding this question, please leave it in the comment section. Let's move to question number 34, which is October-November 2018, question number 9, paper 1-3. A curve has this equation and the line have this equation. Show that for all values of k, the curve and the line they meet. So the curve and the line they meet. We need to find out all the values. So it means first of all we'll put the y's and y's equal so that we can find out the equation of intersection. 2x square minus 3x plus 1 equals kx plus k square. So it will be 2x square minus 3x minus kx plus 1 minus k square equals to 0. Now if we simplify, it will be 2x square plus x minus 3 minus k plus 1 minus k square equal to 0. Now we are going to use the discriminant, and he says that the line and the curve they just meet. So there can be two possible scenarios, which will be b square minus 4ac greater than and equal to 0. So we'll put b square minus 4ac greater than and equal to 0. So minus 3 minus k whole square, 4 times 2 times 1 minus k square greater than and equal to 0. If we expand it, we'll have 9 plus 6k plus k square minus 8 plus 4k square greater than and equal to 0. No, it will be 8k square. Yeah, it will be 8k square. So it will become 9k square plus 6k plus 1 greater than and equal to 0. So this is the equation we have. Now we can see this is the identity directly. This is 3k plus 1 whole square greater than and equal to 0. So what do we need to do? We need to show that for all values of k, the curve and the line, they meet. So this is the values of k for which the curve and the line, they meet. So this is k will be minus 1 by 3, and we can see that. Okay, let's move forward to the next part. State the values of k for which line is tangent to the curve. So for the line to be tangent to the curve, let me take this equation of intersection from here that we found in the previous part, and we know that the line and curve, they are tangent. It means that b square minus 4ac, it will be equal to 0. So the value of b is 3 minus k whole square, and minus 4 times 2 times 1 minus k square, and it will be equal to 0. 9 plus 6k plus k square minus 8 plus 8k square equal to 0. So the equation you will have will be 9k square plus 6k plus 1, and it will be equal to 0. Now the two factors that we can have from here is 3 and 3. So 9k square plus 3k plus 3k plus 1 equals to 0. 3k is common, so 3k plus 1 is common, 3k plus 1. So the two brackets will be 3k plus 1, 3k plus 1. So the value of k will be negative 1 by 3. So this is the value of k, and we have found the value of k. Find the coordinates of the point where the line touches the curve. Now we have the value of k. We will substitute this value of k into the equation of intersection. So it will be 2x square plus x bracket 3 minus 3 plus 1 by 3 minus 3 plus 1 by 3, which is minus 8 by 3 minus 8 by 3 plus 1 minus now for this it's 8 by 9, and it is equal to 0. When you'll simplify, we have if we simplify we can take the LCM as 9, so it will become 18x square minus 24x plus 8, and it will be equal to 0. So further simplify, 9x square minus 12x plus 4 equals to 0. So it's 36. So 36, yeah, the two factors that we can have is 36. So it can be yeah, it can be minus 6 and minus 6. So 9x square minus 6x minus 6x plus 4 equals to 0. So 3x is common. So you will have 3x minus 2 minus 2 inside. So 3x minus 2. So the two brackets will be 3x minus 2, 3x minus 2. So the value of x that we will find from here, let me do it here. The value of x will be 2 by 3. The line line in the curve, the way they are tangent, that value of x is 2 by 3. And the curve, the other one we can find y is equals to 2x square minus 3x plus 1. Yeah, it's y is equals to 2x square minus 3x plus 1. So if we substitute the value over here in this, it will be 2 bracket yeah, the value for y is 1 by 9, minus 1 by 9, sorry. So the coordinates are, let me write here at the bottom, the coordinates are 2 by 3 comma minus 1 by 9. Let's move forward to the next question, question number 35, which is May June 2019, question number 2, paper 1-1. The line y 4y equals to x plus c, where c is a constant, is tangent to the curve. So tangent to the curve means that when you'll find the equation of intersection, the discriminant for that, it will be equal to 0. At the point P on the curve, find the value of C. So it's easy and simple. What you can do is you can make y the subject for both of them. So it will be x plus c divided by 4, and over there you already have it. So let's substitute it there. It will become x plus c divided by 4 whole square x plus 3. So we are finding the equation for intersection. So if we expand it, it will be x square plus 2xc plus c square, and it will be equals to 16x, because 4 square is 16. So 16 times 3 is 48. We'll simplify. So x square plus 2xc minus 16x plus c square minus 48 equal to 0. Now we know that the discriminant has to be equals to 0. So it will become b square minus 4ac will be equals to 0, which will be 2c minus 16 whole square 4 times 1 times c square minus 48 equal to 0. If we expand it, we'll have 4c square minus 4 times 16, which is 64, 64c plus 16 square is 256 minus 4c square plus 4 times 48, which is 192, and it will be equal to 0. 4c square and 4c square cancels out. So 256 plus 192, 448. So minus 64c equals minus 448. Negative and negative cancels. So divided by 64, the value for c will be 7. Yeah, if there is any query you can ask in the comment section. Let's move to the next part. The next part says find the coordinates of P. Now what is P? P is the point where the line and the curve they meet each other, or you can say they are tangent to each other. So we already have the equation for intersection, and that is right here, which is we found in the previous part, x square plus 2xc minus 16x plus c square minus 48 equal to 0. We already have the value of c as 7, so we'll substitute the value of c as 7 over here. So it will be c is 7 we found in the previous part. So it is x square plus 14x minus 16x plus 49 minus 48 equals 0. So x square minus 2x plus 1 equals 0. So it will become x square minus x plus 1 equals 0. So the two brackets that we will have, it will be x minus 1 and x minus 1. So the value of x where the line and the curve they are tangent, that value of x coordinate is 1. We'll substitute into the above to find y, and the value for y we can substitute over here. For example, y equals x plus c divided by 4. So 1 plus 7 divided by 4, 8 divided by 4, that is 2. So the coordinates for P are 1, 2. Let's move to the next question. Question number 36, May June 2019. Question number 1, paper number 13. The function is defined by f of x for all set of real values. Express standard form into complex completed square form. So it's simple, x square minus 4x, whatever is the coefficient of x, we are going to do the half of it, we are going to add the square of it, we will subtract the square of it. So the first three terms they make the identity, x minus 2 whole square minus 4 plus 8. So the answer will be x minus 2 whole square plus 4. Okay, let's move to the next question. Next part, sorry. The next part says that hence find the set of values of x for which the function is less than 9. He says f of x is less than 9, giving your answer in the exact form. So it means that you are not supposed to use the calculators. So let's see. We already have found f of x in completed square form. So this word hence tells you that you need to use your answer from the previous working. So that is x minus 2 whole square plus 4 less than 9. So it will become x minus 2 whole square minus 5 less than 0. Yeah, I hope that is clear to you so far. Now we will make this thing into the identity form. How identity? Let me show you. And which identity? Let me write it over here again. It's a square minus b square, which is equal to a plus b and a minus b. Let me minimize it and move it to the right. Okay, now I'll explain it to you. This is going to come as it is, and for the next one, can I write square root of 5 whole square? Will it still be 5? Because square and square root, if you cancel them, they still be 5. But now this look like the identity a square minus b square. Now once we will add them like this, and the other time we will subtract them like this. I hope this is clear so far. Now we will sketch the graph. Let's sketch. For sketching the after sketching, we need to know what are the two critical values. The critical values are one is this one with the opposite signs. It's going to give you 2 minus square root of 5, and this one is going to give you 2 plus square root of 5, because when you put it equal to 0, the sign they get changed. So this is going to be 2 minus square root of 5, and this will be 2 plus square root of 5. Now since it says that the less than 0 means the region below the x-axis, so the final answer will be 2 minus square root of 5 less than what is the constant, for x less than 2 plus square root of 5. So these are the set of values of x for which this inequality satisfies, and you need to give your answers in exact form, which means that you need to give your answer in the form of square roots. Let's move to the next question. Question number 37, October November 2019. Question number 3, paper 1-1. The line y is equals to ax plus b is tangent to the curve at, this is the curve, at the point 2, 6. Find the value of the constant a, b and c. So he says that you need to find out, you just need to find out the values of a, b and c. The line and the curve, they are tangent to each other, and the coordinates are also given to you. So what we are going to do is, we are first of all going to find out the dy by dx for that. So dy by dx will be 6x square minus 10x minus 3. So this is the dy by dx, and we can find the value of dy by dx, which means we can find out the gradient, which by substituting the value of x as 2. So if I substitute the value of x as 2 in here, so it will be 6 times 4 minus 20 minus 3. Yeah, so the dy by dx will be 1. So if the value of dy by dx is 1, look at the next one. Let's find out the dy by dx for the other. So the gradient has to be same for both of them. So it says that dy by dx for the other one, if I find the dy by dx, it will be a. So they both need to be, so it means that the value of a is 1, because the line and the curve, they are tangent to each other. So it means that the gradient at that specific point is going to be the same for both of them. So that's simple, we found the value of a. Now let's find the value of b. For finding the value of b, we will substitute the value of the coordinates, which is 2, 6, and we will substitute the value of a, which is 1. So let's substitute the value of these, which will be which will make it y is 6 equals 2 times 2 power 3 minus minus 5 to the x power 2 minus 3 power plus c. So if I simplify, I can find the value of c from here. So the value of c, it will be 2 times 8, 16. So 6 minus 16 minus plus 5 is 20 plus 6. So 6 minus 16 plus 20 plus 6. So the answer for C is going to be 16. So the value of C will be 16. We can find the value of B as well. How can we find the value of B? The value of B can be found by substituting the value of x and y and a in the line equation. so which will be 6 equals to a is 1, x is 2, and b, the value for b will be 4. So let's move. I hope there is no question regarding this question. If there is any, please leave it in the comment section. Let's move forward to the next question, which is question number 38, October November 2019, question number 6, paper 1-1. A straight line has the gradient m and passes through the point 0, -2. Find the two values of m for which the line is tangent to the curve. So he has given you the coordinates, he has not given you the equation of the line. So the very first step is to find out the equation of the line. So the equation of the line will be y, the gradient is given to you as m, and the y-intercept is also given to you as -2. Y is equals to mx plus c. So this is the equation of the line. I have used the things that was given to me in the first line, equation of line. Now in the second line, he says that the line and the curve, they are tangent to each other. So for being tangent to each other, I need to put the line and the curve equal to each other. Just a second. Okay, now what do we need to do? We need to put the line and curve equal to each other, which will be x square minus 2x plus 7, and it will be equal to mx minus 2, x square minus 2x minus mx plus 9, and it will be equal to 0. Now after that, x square plus x minus 2 minus m plus 9 equals to 0. Since the line and the curve, they are tangent to each other, so it means that b square minus 4ac will be equal to 0. So b square minus 4ac will be equals to 0. So let me substitute them here. 4 times a times c, which is 9. So 4 plus 4m plus m square minus 36 equals to 0. So m square plus 4m minus 32 equals to 0. So the two factors will be 8 times 4. So 8 times 4, it will be m square minus plus 8m minus 4m minus 32 equals 0. M is common, so m plus 8 minus 4 m plus 8 equals 0. So the two brackets will be m minus 8 and m minus 4, which will be equal to 0. So we can find the two values of m from here. One will be minus 8 and the other will be plus 4. Now if you read the last portion of the question, it says for each value of m, find the coordinates of the point where the line touches the curve. Now we are going to for m equals minus 8, we are going to use the equation of the intersection. The equation for intersection is right here. All we need to do is we need to substitute the value of m as minus 8. Yeah, we need to find the coordinates. So if I substitute minus 8 here, it will become plus 8 because it was minus m. Equation will become x square plus 6x plus 9 and equal to 0. So it will be x square plus 3x plus 3x plus 9 equals to 0, x plus 3 plus 3 x plus 3. So the value of x at m equals minus 8 will be minus 3. Now we'll substitute this value of x and m into the equation of the line, which is right there. Y equals to, the value of m is minus 8 minus 3 minus 2. So it's 24 minus 2, which is 22. So this is the coordinate of one point. Now we'll find out the coordinate of another point. Just give me a minute. It will be x square. Now that is going to be for the value of m as 4. For the value of m to be 4, it will be x square. Minus 2 minus 4, it will be minus 6x plus 9 equals 0. So x square minus 3x plus 9 equals 0. X as common, minus 3. So it will be the value of x from here that I will get will be 3. Now I can substitute the same value in that, which will be the line y equals to mx minus 2. The value of m is 4. The value of x is 3 minus 2. 12 minus 2 is 10. So the two coordinates, possible coordinates where the line and the curve, they are tangent to each other. Let me write them here. One is going to be minus 3 comma 22, and the other one will be 3 comma 10. I hope there is no question so far, but if still there is any question, please leave that in the comment section. Let's move to the next question, question number 39, which is October-November 2019, question number 6, paper 1-3. A line has the equation y is equals to this and the curve has equation this. Find the set of values of k for which the line and the curve meet at two distinct points. So two distinct point means that b square minus 4ac will be greater than 0. Before that, we are going to find out the equation of intersection. For finding out equation of intersection, it will be y equals to y, and that will be x square minus kx plus 2, which will be equals to 3kx minus 2k. Now it will be x square minus kx minus 3kx plus 2 plus 2k and equal to 0. Now we know that b square minus 4ac has to be greater than 0 because the line and the curve, they are intersecting at two distinct points. So it will be minus k minus 3k whole square minus 4 times 1 times 2 plus 2k greater than 0. If I expand it, it will be k square. So it will be k square. We can simplify this instead of that, and in minus 4kx, it will become minus 4kx. So it will be minus 4k whole square, which will be 16k square minus 8 minus 8k greater than 0. So if you simplify, it will be 2k square minus minus k minus 1 greater than 0. So the two factors will be minus 2 plus 1. So 2k square minus 2k plus k minus 1 greater than 0. So if I solve it further, it will be 2k as common. So k minus 1 plus 1, k minus 1 greater than 0. The two brackets will be k plus 1, k minus 1 greater than 0. If you sketch the graph, the two critical values, one critical value will be minus 1 by 2k, and the other critical value will be 1 by 2, sorry, over here negative 1 by 2. The other value for k will be plus 1. So and it says greater than 0, so it means the region above the x-axis. So region above the x-axis means these two parts. So one answer for k will be less than minus 1 by 2, and the other answer for k will be greater than 1. Yeah, I hope makes sense to you all. Let's move forward to the next part. For each of the two particular values of k, the line is a tangent to the curve. So there are two values of k that you have found out, and one value of k is minus 1 by 2, and the other value is plus 1. He says that the line is tangent to the curve. Show that these two tangents meets on the x-axis. So we know that the value of k is minus 1 by 2 and plus 1. So, and we know that for each value we have the equation over here. We have the line is tangent to the curve. So the line, where is the line? The line is y is equals to 3kx minus 2k. Y is equals to 3kx minus 2k. So if I substitute, and this is going to be the same here, 3kx minus 2k. So the line equation will become 3x minus 2 here. This will be the equation of line, and over here it will be minus by 3 by 2 x minus plus 1. This will be the equation of line for the value of k to be minus 1 by 2. Yeah. Show that these two solve them. We need to solve them simultaneously. Let's solve them simultaneously. It will be 0.5 it will be minus 1 minus 1, so, and 3 minus 1 and 2. Yeah, the value of x, when we will solve them simultaneously, we will solve these two simultaneously. So if we solve them simultaneously, the value of x that we will have will be 2 by 3, and the value for y that you will find will be 0. So since the value of y is 0, the tangent meets the x-axis. So you can write, thus the tangent meets at y-axis. I hope that is clear to you all. Let's move forward to the next question. which is question number 40, May June 2020. The equation of the line is this. The equation of the curve is this. Given that the line is tangent to the curve, express m in terms of c. So line and the curve, they are tangent, so this is going to become y equals to 16 divided by x. So it will become 16 divided by x equals mx plus c. So it will be 16 equals mx square plus cx. You need to express m in terms of this, so it will be 16 minus cx equals to mx square. So m will be equals to 16 minus cx divided by x square. We were supposed to make m the subject, so that's how you make m as the subject. Given that this and that, given that the line is a tangent to the curve, oh, he says the line is tangent to the curve. Okay, tangent to the curve, so we have to make it an equation first. Mx square plus cx minus 16 equals to 0, and he says that they are tangent, so it means b square minus 4ac, it will be equal to 0. So it's c square minus 4 times m times minus 16, and it will be 0. So it's 64 c square plus 64 m equal to 0, and m will be equal to minus c square divided by 64. We were supposed to find the value of m when the line and the curve, they were tangent to each other. Let's move forward. Given that m is equals to minus 4, find the set of values of c for which the line intersects the curve at two distinct points. So we know the value of m now. The value of m is minus 4, and we need to find they are intersecting, so it means that we need to put the y's and y's equal to each other. We already have found the value of y's. The equation that we have is mx square plus cx minus 16 equals to 0. The value of m is minus 4 plus cx minus 16 equals to 0. They are intersecting intersecting at two distinct points, so which means that b square minus 4ac will be greater than 0. Let's substitute the values. C square minus 4 times minus 4 times minus 16 will be greater than 0. It will be 256. So c square minus 256 greater than 0. So c square minus 16 square greater than 0. So it can be written as c plus 16 and c minus 16. If I sketch the graph, it's going to look like this. The two critical values are going to be minus 16 and plus 16. The graph says greater than 0, so it means the region above the x-axis. So above the x-axis, so there are going to be two inequalities, c to be less than minus 16, and the other one will be c to be greater than plus 16. Let's move forward to the next question. There are just two more questions left, and that will be all the questions up till 2020. Question number 41, May June 2020. Question number 6, paper 1-2. The equation of the curve is given. Given that the line is this, is tangent to the curve. So we are very well aware that whenever he talks that tangent to the curve, it means b square minus 4ac will be equal to 0, but of the equation of intersection. So for finding out the equation of intersection, we'll put the y's and y's equal to each other. So it will be 2x square plus kx plus k minus 1 equals to 2x plus 3. So 2x square plus kx minus 2x plus k minus 4 equals to 0. Now we know that they are tangents, so it means b square minus 4ac, it will be equal to 0. So let's substitute the value of b, which is k minus 2 whole square, 4 times 2 times k minus 2, and it will be equal to 0. So if we expand it, it will become k minus 2 whole square, it will be k square minus 4k plus 4 minus 8k plus 16, and it will be equal to 0. So k square minus 12k plus 20, and it will be equal to 0. So the two factors will be minus 10 and minus 2. So you will take k as common, k minus 10 minus 2 will be common from the next. So the two brackets will be k minus 10 and k minus 2. So the two answers of k will be plus 10 and the other answer will be plus 2. Now he says that it is now given that the value of k is 2. The value of k is given to you as 2. Just a minute. Let's move forward. He says that it is now given that the value of k is 2. Express in form of y equals to this. The value of k is 2. Let me write it down. Equation of the curve is y equals to 2x square plus 2x plus 2 minus 1 will be plus 1. So this is the equation of the curve that we have. We need to change this equation of a curve into completed square form. So for that we will take common from the first 2 only. It will be x square plus 1x plus 1 outside. So whatever is the coefficient of x now, we'll do the half of it. We'll add the square and we will subtract the square of it. So if we simplify, it will be x plus 1 by 2 whole square minus 1 by 4 plus 1. So if you further simplify, it will be 2 bracket x plus 1 by 2 whole square minus 1 by 2 plus 1. The 2 outside the bracket will multiply with both of them. So the final answer for the completing square form will be 1 by 2 whole square plus 1 by 2. Now hence state the coordinates of the vertex. The vertex or the turning point coordinates, they both are found from the completed square form, which will be minus 1 by 2. This portion is going to give you the x coordinate. When you will substitute this thing equals to 0, you will find the value of x coordinate from here. And similarly, this exactly the one written at the end, this is always going to be the y coordinate of the turning point. So these are going to be the coordinate of the turning point or the stationary point or the vertex. The last question up till May-June 2020, which is question number 42, May-June 2020, question number 1 from the paper, and paper is 1-3. find the set of values of m for which the line with equation this and the curve with equation this intersect at two distinct points. So when we talk that they intersect at two distinct points, so we mean that b square minus 4ac will be greater than 0. So before that we will find out the equation for intersection, which will be we will put y equals to y, and that is 3x square plus 2x plus 4, and we will put it equals to mx plus 1. So 3x square plus 2x minus mx plus 3 equals to 0. So we know that b square minus 4ac has to be greater than 0. We'll put it in the discriminant, 2 minus m whole square, 4 bracket 3 bracket 3 greater than 0. If we expand, it will be 4 minus 4m plus m square. 4 times 3, 12 times 3 is 36, minus 36 greater than 0. So m square minus 4m minus 32 is greater than 0. So we need to find the two factors. 8 times 4 is 32, so the two factors will be 8m plus 4m minus 32 greater than 0. m minus 8 plus 4, m minus 8 greater than 0. So m minus 8 and m plus 4 greater than 0. So the two critical values of m will be positive 8 and minus 4. So if I sketch the graph, it's going to look like this with the two critical values. One is going to be minus 4, the other will be positive 8. And since it says that greater than 0, so greater than 0 means the region above the x-axis. So this is the region he is talking about. So the two in set of values inequality for k, set of values of m, they will be m will be less than minus 4, and the other m will be greater than plus 8. Yeah. So if there is any question regarding any of the questions here, please leave that in the comment section. I'll answer it as soon as possible, and don't forget to share it with your friends. All the papers from 2011 up till 2020 for quadratics are here within all these parts that are available for you. This was the last part, and don't forget to share with them so that it can help them to understand the concept well. Along with that, it will definitely help me in growing my channel as well. So but again, I hope the concepts are pretty much clear to you all. For the next concept of functions, you can check out the next videos for functions in the separate playlist. Thank you. Take a good care of yourself. Good luck. Allah Hafiz.